All right, everyone. Hey, Chris Mattson here. In this video, I'm going to solve the CAD Fluency Test for the BMW Rim. I'm going old school today. Have the engineering drawings printed out on B-size drawings. And it's going to be great. All right, I'm just going to solve this test the way that I would solve it. You should know that there are multiple ways to solve this test and get an acceptable result at the end. But should you want to know how I did it, this video will show you. All right, I'm going to now just review for a moment the things that need to be done on the test. I'm looking at the test questions. What are the test questions telling me? Number one, I can actually see that I have been given a rim. I've been given a tire, which is now open in my CAD system right now. I've downloaded it. I can see that it has three configurations: the default configuration, the 20-inch configuration, and the 23-inch configuration. I can also see that part of the test here, the goal of the test is for me to make a BMW car rim that will actually adjust its size to the wheel when the wheel configuration is chosen, is changed. So I need to model the rim. I'm going to need to use master modeling for that to link the two files together. I then need to adjust the appearance of the rim and add the BMW logo. I need to demonstrate that the master modeling is working by seeing that it adjusts. I need to run an interference analysis, and I need to choose lug bolt clearances. That's what I'm going to have to do. So I'm going to jump right into this and start my CAD modeling. I am just going to spend a minute looking at the engineering drawings for the rim. This is going to help me just sort of orient myself to what's going on here. I have a sense for what I want to do, but give me a second to look at this. Okay, so the rim, in my view, is essentially three things. Even though it's one part, it's got three sort of major elements to it. One is the complete largest diameter part of the rim. That's going to match the profile of the tire. So I think I'm going to model that first and just see if I can get it to move correctly. Then I have the spokes, which there's 5 of them, and then I have the center hub. So these three things, I've got to sort of conceptualize how I'm going to do them. So for the rim, the outside part with the largest diameter, I'm going to use surface modeling. I'm going to go get the surfaces off the tire that need to match. And then I'm going to use a Revolve to get the inside part of the rim that's not matching with the tire. And then I'm going to turn that into a solid. And then I'm going to pause and check to see if this is working. Then I'm going to do some lofts to create the rim spokes. And I can see in the drawing that there are a couple of cross sections that are defined. And that should help me to go loft from one cross section to a next, to a next, to a next. And then I should be left with pretty much a rim without a hub. Then I'm going to go create a hub, which it appears I can do just by making a revolve. I'm thinking through this right now, by the way. Make a revolve, add in some holes, and then I'm going to go make some appearances, etc. So we are now about, I didn't check my time when we started this. It's about 2:45 when I started this, so we're a couple minutes in, and I have a sense for what I'm going to do. So the first thing I'm going to do now is take this part, and I'm going to make an assembly from this part. And I'm going to have to get all my namings just right. This part's just kind of critical when we're getting started with this. Let me actually get into the units that I want, which is inches. Okay, into IPS. Now I'm going to come over here and save this thing. And I'm going to save this thing as the wheel. Actually, let's do it this way. Cam 37 wheel. Just gonna put another thing back here. Just help me keep track of what's going on with that. Okay, now I've saved this thing. It is in here. And now I'm going to create a new part right in this assembly, and that is going to be my rim. Okay, so I better get a name for this. Cam 37 rim. 22. Okay, what does this want me to do? It actually says in the bottom left corner of my screen, select the face or plane to which to position the new part. I'm gonna have to pop those suckers on there, and I'm going to click the front plane. And now my front plane on my part is lined up with the front plane on the existing part, and it's called Cam 37 Rim, which is what I wanted to call it. And so I'm gonna switch this model from MMGS to IPS, get us all in the same units. I'm gonna jump out of this. There's nothing in this file right now, but I'm just saving it in order to get all the sort of files linked together the way that I need them to be linked together. So I think I've accomplished that now. What I'm gonna do now is go in and edit the part. I could open the part and edit it in its own window, but I'm gonna do master modeling, so I want to just edit the part in place. And I can see by what's in the top right corner of my screen right here that I am editing in place. And what I can do now is go in and get the surfaces that I want to take over into the rim model. I don't believe I'm gonna need any of these planes to look at right now, so I've turned this into a cross section so I could just see nicely into this part. And I'm going to go into surfaces. This is how I like to use master modeling. I'm gonna go to offset. I'm gonna set my offset to 0. This means I'm gonna copy surfaces now. And the surfaces I'm going to copy are this one, this one, this one, and this one, those 4 surfaces. Okay, I'm gonna get this one, this one, this one, and that little one that's right there. And I'm gonna copy those. And I believe that worked, but I can't tell because I just can't see that on here. So let's save this. Actually, I could go like this and see that there should be an offset in here. Yeah, there is an offset in there. I'm gonna save that, or get out of it at least, and save this. And now we're just gonna go open up this rim file in its own thing and see if we've got anything. Now, sometimes this happens, which I think is a graphics problem. If I just click this rebuild, we will see our stuff, and we do see it right there. So what we have on this is the parts of the rim that are going to match the tire exactly. So I think it will help me to, again, just go look at this from the cross-section point of view, which is what I'm gonna do now. Okay, now I'm gonna go back to this engineering drawing. I can look at section AA. Section AA is going to tell me what I need to draw between these points, between this and this, in order to get that just right. Okay, so why don't I do myself a giant favor and do this pretty much exactly the way it's oriented in the engineering drawing. It's not a gigantic favor, but it's a little favor. Okay, let's go put a new sketch on here. Now, this always sort of drives me nuts, which is I can't tell which way that's going. Okay, so I have to rotate it just a little bit and then go back there. Okay, so if down here, okay, yeah, I'm trying to envision what we're seeing here. Okay, I'm gonna do this in 2 parts. It looks like one part has to be something very similar to this. You know, something very similar to this. And that's going to be rotated around, you know, revolved around as a surface. And that's going to create basically the outer edge of the rim. And then I'll create the other geometry as another revolve and try to put them all together. So that's what I'm gonna do. I'm just gonna keep looking at this. Okay, now, okay. I'm looking at the engineering drawing and realizing this needs to be 6 inches. And I'm also realizing that the center of this needs to be coincident with this. Whoops, that's not what I want. Get out of the dimensioning thing. Get that, hold shift, hit this, let go, get coincident. Okay, great. All right, now I need to get this point to line up with that point. Did that just do it? See if we can make this one do the same thing. I'm not entirely sure that will work, but looks like that just became coincident. That's not how I would have normally done that. Maybe on the next one I'll show you what I would have normally done. But let's get a few dimensions on this and see if we become totally constrained or not. Okay, so from here to here, we have a certain distance, and that's 0.26. Okay, I would have hoped that that would have become fully constrained, which it is not. So maybe what I thought worked a minute ago did not work, which means I'll be able to show you what I would have normally done. See what we can move here. Oh yeah, this thing's just like, okay, that one over there seems to be connected, and this one over here seems not to be connected. I don't think that solved it. Okay. Well, I'm not entirely sure why this one wants to connect itself to that point and the other side does not. I'll just try one more thing real fast here, which is, again, not what I would have normally done, but... Okay, yeah, I can't get that piece just right. So what I want to do is use... I want to use a convert entity. And what I want to do here, convert entity, there's 3 things I can do: convert entity, silhouette entity, and intersect curve. Let's try the intersect curve. Okay, I'm on a sketch right now, so it basically is going to look at where does this, yes, it's not the one I want. Let's get rid of that. Clear section. I'm going to see where this thing intersects with the curve. And it put it on there, which is great. That's what I wanted. I'm going to take this, I'm going to make that a construction line because it's not going to be part of my actual geometry. Now I can come in here and get this point and make them coincident. And now I'm fully defined. Now, however, this side's not correct, so I probably have to do that same thing over here. Before I go on too much further though, I have to realize that this thing was a full circle. And so when I intersected this surface with this plane, it intersected both here and up here. Yep, see, we don't want this thing. So I'm going to click on this guy, hit the delete button. That's great. All right, now, not entirely sure why that one wanted to be connected before. I thought I was going to have to do this convert entities thing. Okay, so intersect curve. I want to intersect this curve with the plane I'm sketching on, which is what it just did. That's great. That's exactly what I want. I'm going to take this, make it for construction. Now I can take this point and make it coincident. And now we should be fully defined. And down at the bottom, it says we're fully defined. So that is great. All right. Excellent. I should be able now to take this sketch and revolve it around an axis that's not in here yet. This axis and, well, that yellow axis that's right there. Okay, let's take sketch 2 and axis 1 and do a surface revolve. Just that one. It's looking good. Okay, excellent. That is the center part of my, or that is the part of my tire, that's the part of my rim that matches my tire. All right, now I could stop and do a test. Probably a good idea to do that. I'm gonna see if I can just make the rest of this right now. So, and when I mean the rest of this, I mean the rest of the profile that will get me a closed cross-section that I can then turn into a solid. So I'm gonna go back over to here and I am going to sketch on this plane. Let's look normal to that. Yeah. Like I said, I have to rotate that to know sometimes what it's looking at. Okay, I said before that I was going to work down here where it looks just like the engineering drawing. Do I really want to do that? That's interesting. What is that? Okay. I don't know that I want that surface that's dangling right there. Okay. We actually might have a little problem there. Let's save this. Okay, let's get out of this sketch. Unfortunately, that means they're going to not have sketch 3 in the model. I sometimes love it when the sketches are all sequential. Okay, save this thing. Somehow I've got this extra thing here that I don't really like. So I'm going to go back into the one that is the wheel. That's my assembly. Okay, here's my part. You can see this. Okay, I got one surface here, one surface here, one surface here. When I grabbed this other surface in my offset, I did not grab the right one. So what I need to do is edit this in place, open the part. In here then, I want to go into my offset and I want to edit this feature. And I want to remove face 4, delete. And so here's delete this one as well. Okay, but I want to add this thing, which is face 9. Okay, that one was not there before. Now I got to go do this to the other side. Okay. Whoa, that was horrible. Okay, I'm not sure which one that is. So if I click on it, it tells me it's 8. Then I can go delete the 2 8s. Delete, delete. And I want to actually get that one, which is face 10. Excellent. So that's what I wanted. Let's jump out of this thing. Hit save, save. Now let's go over to the rim model. Ah, yes, that's looking a lot better. Okay. So I was noticing that while I was looking at the engineering drawing, there was no jet out to the side the way it had appeared. So let's make a new sketch here. I'm gonna try to close up this surface now. Part of what we have going on in this surface is, okay, first of all, I don't wanna do this twice. So I'm only gonna do half of it and mirror it. Okay, which half am I gonna do? I'm gonna do the half that's basically dimensioned, just to make it easy for me. Okay, then after some amount of time, it jets down and then it goes over to here. I don't know exactly where it goes. I guess I'll just go like that. And then there's something like this. And then there's some sort of arc. Basically like this. Something very similar to that going on. Did I miss any of this? Okay, great. So now what I can do is just start dimensioning out some of this stuff. And it looks like everything is dimensioned to this right here. I think that was part of what we did earlier. Let's convert this whole entity into my model. Yeah, I think that's good. First of all, what I'm going to do is, being slightly chaotic here, and I don't want to be, but I'm thinking in my head I can make this work. That's usually dangerous, right? I should be slightly more thoughtful here. Okay, for construction, turn all those into construction. This point is an important point for dimensioning all this other stuff. Like from here to here, 0.96, okay? And from here to here, 0.26. Okay, let's just move that so we can read it. Oh, great, okay. And now from the center plane over to this edge, oops, is a certain amount. And that value is 4.65. And then from here to this point is, nope. That one is the 4.65. So I'm gonna do 7.5 right now because I don't want to make the entity go to nothing. So this one's 4.4. And then this one right here is 4.65. Okay, so that part's defined. It's all nice and colored black. All right, so then we got to get this thing fixed up down here. All right, first of all, we need this and this to be tangent to each other, which that's better. Okay, then this has a particular dimension associated with it, and it is 0.3. Okay, so that's like how that is. And then this point, I think this is kind of like, yeah, okay, that's floating around. And now we want to get this and this basically lined up and tangent. So I'm gonna go get this little line right here. That's gonna be easy, not easy. Yes, we're gonna do the same thing we did last time, is take this guy, wherever it is, this guy, come on, this guy. Okay. Why can't I do that right now? Can I do this one? No. Won't let me do any of those. Cancel that. Okay, so let's just save this sketch for a minute. It's like totally underdefined. Let's go right up above this sketch. And let's see if we can, let's see, do we want to do that? Now, what I was doing should have worked. So let's go edit this sketch. In this sketch, I want to convert entities. I want to intersect. Here we go. It's highlighting. What if I do this one? Okay, don't want that to happen. Clear that. There we go. Perfect. That's what we wanted. There's some sort of resolution problem where it was not able to pick up my mouse click on the screen. So what have I done? Did I just turn this into construction line? Yes. And then I want this guy and this guy to be coincident. And I want this and this to be tangent. Oh, great. I think that's actually what I want right there. Yeah, that's looking pretty great. But remember, I also have this little piece that I just copied is also floating up here. Look, and there's another one right there that I didn't delete before, so that wasn't cool. Don't know what that is. Let's just delete this thing because we don't want that. That might come back to haunt us later. Okay. What do we have? What do we have? That's looking pretty good. Let's try it. Okay, sketch 4 is fully defined. We want to take sketch 4 now and create a surface revolve. And we're going to do a surface revolve here. This is what I expect it to look like so far. Okay, great. Then we want to take surface revolve and mirror it around this plane. At least this is how I'm choosing to solve this. Okay, did that work? Okay, now I have a surface. And dang, I should stop and test this, but I'm actually just going to see if I can get this to turn into a solid by knitting it. Okay, back into surfaces, into knit. What do I want? All that stuff. Did I grab it all? Usually it changes colors. Okay, cannot be joined manifold bodies because more than 2 body sheets cannot be joined together at a single junction edge. Okay, so let's do this. Just actually see what's going on here. Gonna look close at this. Okay, so first of all, let's take surface revolve 1, and let's take Let's take that one and surface revolve 1, and let's just see if we can knit this together. Merge this. Okay, whatever. Haven't chosen that yet. Let's open up this guy to look at that. Okay. Why will that not let me pick that? Cancel this. Knit surface. Huh. That's odd. Okay, before we go too much further, let's just pause for a second, take a little breather. Let's do the test that I had hoped to do a minute ago. Okay, here's my part. Let's get out of this cross section. Get out of this. It's just a surface right now, so that's not great. And is that missing? Okay. It's kind of hard for me to see what's going on in there, whether there's a missing surface or not. There's not. Just the reflections. Here, probably if I do this. Let's go to these real graphics for a minute. Okay. Now the question is, save this. Save. Let's make sure our other one is saved. Yes, it is. Into our configurations. Oh, okay. What I gotta do is this. I come into my tire. I come up here. Already on my 23-inch configuration. Okay, 22-inch configuration seemed to work. Default configuration. It's just the same as the 20-inch configuration. 23-inch configuration, that works, okay. So that's moving the way that I want it to. Default. Let's go into the default. Okay, so that's great. Now we know that's working. Let's go turn it into a solid. That's what we gotta do next. We're about a half hour into the test. Wow, that took a little bit longer than I wanted it to. Into my rim. Okay. Turn this off. Okay, now what I was hoping would happen, so I'd say knit surface, select that. Let's see if we can just merge these. Okay. Obviously I have a problem here in one of these. And part of my problem is that I better go back and check those surfaces. Because I might have more than one surface on top of each other trying to become one thing, which is what I think that error was telling me. So I'm going to go back into this revolve. I'm going to open this revolve, edit this feature. Okay, here's the problem. Okay, I've got this thing right over here, down at the bottom, that's revolving around, while at the same time I have this thing right here revolving around, which is probably the reason why we're having this mistake. Let's try to delete that. Can I do that? I need to first, am I editing that sketch? Edit that sketch. There we go. Let's delete this entity, delete that. Okay, I still get the same shape because I was revolving from the bottom, but I was also revolving from the top. And that was that caused me some trouble. Save that. Okay, now let's see if this will solve for us. I'm not sure if it will, but I really want it to. Of course, it doesn't matter how much I want it to do it. It's a matter of whether the program will accept it or not. And it turns out that was the problem that we were having. So we worked through that largely because I read the error, and although I didn't understand the error all the way, the error was saying I basically can't have two things on top of each other merged. At least that's how I was interpreting that. So this is good. Let's save this thing. we better go back and run a quick test in the wheel model. Let's go ahead and look at the cross section. I think it's easier to look at when we're looking at the cross section. There's our two parts. They're both solids at this point. Let's go in and change this from the default to the 23 inch. Okay, great, that worked. Now let's come in here and check out the 20 inch. Great, that worked. And what we're doing here is I'm trying to make sure all my files are linked together. Okay, great, just right. So what is gonna happen now is I'm gonna save this, and I'm basically done with the first part of the rim. Now I need to do the next part of the rim, which is the cross sections, and then I will do the center hub. I'm not sure whether it's better to do the center hub first or the rims, or excuse me, the spokes. I'm also not entirely sure that that matters. So I'm reading now in the drawing. I just need a second to read this. There's a major note about the spoke. The spoke feature is a smooth loft between four cross sections. Section 1 is closest to the center of the rim and is located 2.3 inches from the center of the rim. Section 2 is shown at section CC. Section 3 is shown in section DD. Section 4 is the furthest from the center of the rim and is located on a plane parallel to section DD and tangent to the surface labeled surface A. Great. Okay, let's see if we can do this. So what I'm learning from this is, I'm going to go back over to the rim model. Okay, let's get out of this cross-section view for a second. What I'm learning from this rim model is that I need some reference geometry. And what I need is some planes. And I need this plane to be 2.3 inches away from the hub. The center of the rim, excuse me. Okay, that's where one cross-section is going to be. Now I need another cross-section that's going to be, another reference plane that is going to be 3.08 inches away. Okay, great. I want to draw another cross-section on that. Accept that. And then I'm going to do another cross-section. Well, I got to do a bunch of these things. Okay, so reference geometry plane. Now this one is 8.93. Save that. Okay, and then I need another plane. Okay, so I need another reference plane. I should have 4 when I'm done. 1, 2, 3, and then the one I'm about to make. I'm going to make a plane that is parallel to this. And my second reference is going to be this. And I want it to be tangent to that. Okay, so here's my problem. Is it's trying to put that plane like right over here. It's because this switched to perpendicular. I want it to be parallel. Great, so it just popped it right up there. You can see that? Great. All right, now I have 4 planes onto which I need to draw 4 cross sections. Okay, for simplicity, sections A, C, and D are shown as slices only. Okay, D, C, excellent. Okay. I'm going to start with section CC. That sounds like maybe the easiest one. They're all the same, doesn't matter. Section CC is going to be drawn on this plane right here. Okay, I believe it is going to be helpful for me to look at the cross-section on this. So I'm going to make the cross-section there. Let's flip that. I was imagining looking at it this way, so I'm going to make that happen. All right, that's where section 1 is going to be. This is where section CC is going to be. So I'm going to draw on this one then. Okay, I'm looking at the back side now. Now I'm looking at the front side. Okay, so first of all, I know that there is a line and that line is centered on here. Okay, that's that. I also know that this line is a certain distance away from this, which I can see from section CC is 2.75. It's lower than I thought it would be. Okay, and then I have some other things here. From here to here. Then same sort of thing from here to here. And then from here to here. This one also needs to be centered, so let's go get the center of that. Onto this. And then I have some sort of 3-point arc like this. Okay, whatever. And the next one, another 3-point arc like this. Okay, now it does make sense to me that this and this are probably lined up. Let's just see what happens when we do this. This and this are probably lined up. Okay, let's make this and this equal to each other. That's not what I wanted. Maybe it was what I wanted. I'm gonna line those up. I'm gonna line this up. Great. I think those are the relationships I want. Now I need to get some sizes. This thing here needs to be 3.15. Wow, that's giant. Okay. And then from here to here needs to be 1.35. And then from here to here it needs to be 2.45. And my entire cross section is turned black. And it looks pretty good. Well, my arcs don't actually look right. Oh, I see. There's one more dimension on here. Okay, if I add this extra dimension, it's going to crash, but I'll just show you how that works right now. It's not going to crash. It's going to tell me that this one doesn't want to be that way. So I have to go back into my relationships. Okay, display my relationships. Oops. I have to get into my sketch first of all. Am I in my sketch? Let's do this for a minute. Okay, yeah. I need to go into my sketch. And I need to, I want to display my relationships. Here we go. These were sort of some of the ones maybe around here. Yep, I want to delete this one. Delete. Then there's going to be another one here. Yep. Delete. Okay, great. Now I can pop in my dimension right here, which was 1.2. By the way, the only reason why I knew I got this wrong is that, okay, here's another one of these problems. Let's see, that one is lined up there. Do I need to, let's do this. This one and this one are equal. Whoops. This one, make them equal. Now that's turned black, we're fully defined. The only reason why I knew that was a problem is because I sort of double checked visually to see if that was done right. Okay, so there's one cross section. Now, sections 1 and 2 are identical. So I just did section 2, but I can make section 1 now. Section 1's going to be on here. New sketch on this. Let's take a look at this. Flip that guy around. Convert entities. This one, this one, this one, this one, this one, and this one. And we're done. That's section 1 and 2. Oh, okay, great. That's perfect. Now, I'm going to make a new section on this one. New section. Okay. We're about, I don't know, what are we, 40 minutes into this test? Something like that. Okay. On this plane then, I need to do my next cross section. And my next cross section is going to look very similar to the previous one. But I'm just going to draw it on here. Sometimes I find it easier to not draw the line centered, so I know that I got my center. I come over here and I grab my plane that I want and tell it I want it to be Centered like that. Okay, I'm going to do the same thing at the top. Okay, I'm going to grab the center of that and my plane. Do that thing. Great, excellent. We're almost there. From here, we go up vertical. And I'm going to make another one over here. Here, go up vertical some amount. I'm going to make these two equal to each other. That means they're going to be equal in length. Then I got another 3-point arc from here to here. I'm just getting the basic geometry, as you can tell. Whoops. 3-point arc, I got to do 3 points. I'd only hit 2 points by the time we were done with that. Okay, another 3-point arc from here to here. Great. Now I want these radii to be identical to each other. Okay. We're basically following the exact same model we did last time when we made the other cross section. So I'm going to make those ones vertical with each other. And did this one automatically do that? I don't know if it did, but I'm just going to go like that. Okay. Now what I'm going to do is get some sizes. So it needs to be 1.7. All right, and then this one up here needs to be 1.45. Okay, and then these need to be, does it say on there? No, it doesn't say on there. This guy needs to be 0.28. Okay, that's not cool. What did I mess up on here? Oh, I see. I haven't got this other one on yet, which is this one. This needs to be 0.38. There's my cross-section. It's still blue because I've not placed it in space yet. Okay, so I got this guy and this guy. And this is going to be 4.2. Now we should become black all the way and be fully defined, and we are. So every time we have a cross-section, we are actually trying to make sure that its shape is fully defined and its placement in space is fully defined. We need to save this. I haven't saved in quite a while. That's not cool. All right, now we know that from the note, the giant note that's on sheet 1 of the rim, sections 3 and 4 are identical. So what I need to do then is go put section 4 on this thing. Section 4. Okay, it's upside down here. That doesn't really matter right now. I'm just going to go take all these because I'm going to convert entity on these. And that should give us a nice black set of lines. And that's totally done. So what do I have now? Here's a good view. I have one section here, another section here, another section here, another section here. So what I can do now is do my solid loft, get out of surfaces. I could do it as a surface, but why at this point, okay? Now I'm going to, maybe I'm just going to connect these points for a second because that might help me from not having to mess around with it too much afterwards, but let's see. Okay, does this work? It didn't give me a preview, which is not cool. Okay, what does this say? Okay, well, there is my section. Okay, great. So far, that's looking okay. Let's see if we can pattern this thing. Wow, look, so many planes I don't want to be looking at. I can turn some of those off later, but let's just see if we can get ourselves a circular pattern on this. Going 5, 360. My axis is this one. Will it do it? Will it do it? Excellent. Okay, okay, so I guess I should test this. Okay, let's test this. It's always a good idea to test so we can know. We're at the end of sort of a major element of the test at this point, which is I got my spokes. I'm just examining this. Okay, what's going to happen when this guy becomes 23-incher? That will be the big test. My center should stay the same, and it does. And I get thinned out toward the side. So this is a good time for me to just pause for a minute and look at the image looking at these two images right here to see if it looks right. Okay, so I can see that the spokes have gotten a lot thinner. And that is also what it looks like in the drawing, meaning like it's gotten thinner at the top. In this case, that top spoke. Now if I take my other one and go back to my 20-inch, now of course it looks real squatty. Actually, now that I'm looking at the drawing, I can see there is a radius I need to put in over there. I better go put that in before I forget. So that looks like that worked. I'm going to go back to hang out at the default. I don't know that that makes a huge difference, but I do like to try to do that. Okay, first of all, I noticed both my files are unsaved here. So I'm going to get back into this thing, save it. I just want to make sure my models are nice and clean. And that saves both those parts. So now I'm back into the rim. And looking here at the engineering drawing for a few minutes, a few seconds. Okay, a half inch radius all along these connections right here. So let's go make that happen. Let's turn these off. The reason why I want to do this right now is that I'm actually about done with everything on the outside of the wheel. Yeah, so it's like this, but I just need this like everywhere. Everywhere is not the right word, and clicking the face was not what I needed to do. So that's not good. Delete that. I just need the edge. Edge, wonderful. Edge. Good thing there are only 4 spokes, 5 spokes. Wow, that was hard to pick. Okay, keep going, keep going, keep going. Grab this guy, edge, wonderful. Grab this one, edge. I don't know why it's so hard for me to grab right now. Okay, come into here. Grab, grab, grab. Another one. Oh, come on, edge. 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 Wonderful, wonderful, wonderful. Okay, so now what I need to do is solve the hub problem. All right, so now for my hub problem, I'm going to go back and look cross-section again. I always look at the cross-section because if I am trying to draw my sketch, see, where are we right now? Front plane, right plane. Okay, here we go. If I'm trying to draw on the right plane and I have all this other material in front of it, it's just sort of hard for me to see what's going on. So I prefer to do these sketches and stuff while I'm in cross-section mode. Okay, look, if you don't want to look at all of these planes, you just right-click on it and say hide, right-click on this one and say hide, right-click on this one and hide it. These are planes that were essential to the previous operation. Now I'm just back to my primary planes now. Top, right, and front. Okay, so let's make a new sketch on the right plane. Let's go look at this normal 2. Now I'm looking at section AA. And section AA is going to help me. It's going to help me. So first of all, I'm going to make a revolve. Okay, my revolve is going to look like, from here, down some amount, over here, down some other amount. I can't tell where this is relative to the spoke. Okay, so far it's like that. Better get this centerpiece up here somewhere. Okay. And then there's some sort of arc. It looks like I'm going to have to do this in a couple of pieces. There's an arc that goes something like this. All right, now actually I know I want this arc to not have a divot sort of in the middle. So I'm going to do this trick that we've done many times before, which is I'm going to make that for construction. Then I'm going to grab this and say I want this to be tangent. That's going to get me a nice sort of view there. Okay, now I think I can dimension this. So first of all, from here to here, placing in space, this should be 1.60, excuse me. Okay, and then I have from here to here is 1.25. Oops. All right, and then from here to here is 1.95, or it is 2.95. Okay, and then from here to here is 210. 210. Okay, those are all becoming black, so they're getting defined. And then this over here is 12. Wow, that's quite different. What's going to happen when I do that? Okay, wonderful. And then there's one more dimension, and that is from here to here. It's going to be 4.30. Is that going to work? Yes, it does. It says fully defined. It's great. Let's take this while we have the chance. Okay, take this. Now we're going to do a Revolve boss base. Run this. Wonderful. How's it going to look? How's it going to look? Looking good. Okay, save this. There's still some other stuff that has to happen here, and I might as well take care of it soon while I am thinking about it. Okay. All right. So I need to get a fillet in here. These fillets, you know, when you remember them, you want to do them. Unless it's a bad time to do the operation. Okay, so that one's in there. Then I can actually see that there's another one on here. Which is shown in the other view, which is detail F. And that's this one. Excuse me, did I connect that? This one should be 0.5, I think it said. No, 0.25. Okay. Is that going to work? Okay, now when I look at the drawing, gotta look at detail. Just sort of checking the features to make sure things are looking right. Detail E, where's detail E? Here we go. I gotta do a bunch of holes, right? Okay, I can also see that there are some, get rid of this thing for a minute. There's some more of these guys, fillets, 0.34. Okay. Okay, click, click, click. Why not do those with a circular pattern? I don't know, that's weird. Okay, look, I would have expected it to look like this, nice and smooth along the bottom. I have no idea what happened over here. That's weird. Oh, I see. Okay, take this thing, just accept that for a minute. Looks like my fillet only went on one of the spokes. So I need to go up here to wherever that was, right here. Let's edit this. I want to get that one as well, and that one, and that one. So I guess you can see one of the things that's happening here is I'm sort of like constantly thinking about the model and is it looking right? Okay, so I sort of observe weirdnesses and then ask myself why it is doing that. Okay, now what I need to do is it looks like there's a bunch of holes. Some of them I know they're through holes, which I know from detail F, but I also just know from intuition that I got to put a bolt through this thing so the rim will stay on to the vehicle. And so there's a couple of references I'm going to need to create to do this, because it does appear from detail F that there is a countersink and a counter bore. It looks like there's a sort of weird thing going on there, but in order to make those cuts, I got to make another reference plane. How far away am I? Okay, great. It doesn't matter how far away I am from that surface. Let's be just slightly closer to it because it's a little bit weird to be super far away. But I just need to be above that surface. Okay, now on this one, I'm going to make myself a sketch. And part of what's going to happen is I'm going to put a series of holes on this. And this guy is going to end up being 4.4. And it needs to be a construction line. Okay, I don't know what just happened there. I accidentally did that. Delete that thing. It's a construction line now because it's dashed. That's good. Maybe I can make one entire set of these and then pattern them afterwards. Okay, so let's get out of this. Let's make ourselves now a new sketch on here. I'm leaving that reference circle just sort of as its own sketch. I don't know if that's necessary, but it's what I want to do right now. I think that keeps it just slightly cleaner. Okay, so I need to put a circle on here. And I want this circle to be, I want the center of this circle is coincident. It looks like there's a coincident thing right there with that, but I also want it to be coincident with this. Okay, and that's moved it over. That's great. Let's look at this more directly on. Yeah, great. That's how we want it to be. This one is going to be my through hole. So that's 0.5. Okay. That's that. Okay, so I might have said before, let's make this all as one feature. I didn't mean that. What I mean is let's make a bunch of features and then see if we can pattern all of those features. So I need to go through all on this. Is it working? Okay, yeah. I've gone all the way through that. It's great. Now I need to make a new plane, or excuse me, a new countersink, so to speak. And that countersink hole is going to be actually just concentric with this, which that should have done it. We're an hour into the test now. 0.9. Okay. Now I'm going to cut this. And in detail F, I can see that cut is going to go all the way down until it is 2.2 inches away from that other surface. So the way that this will work, so I'm going to do an extrude cut with that. Instead of blind, I'm going to go offset from surface. And the offset surface that I want is this surface. And I want to be, according to the drawing, 2.2. Where's that going to leave us? Yep, that's about right. Did it work? Did it work? Did it work? Yeah. That's not looking totally right. That's interesting. Let's just take a cross section on this for a second. Cross section that guy. Oh, that's interesting. Okay. That looks right. I was imagining the chamfer would be a little bit different. So there is a 0.2 by 45 chamfer. I had somehow imagined that filling this area, but actually it looks like that would be on this surface. So let's just try that actually. I'm gonna grab this, come up here into chamfer. Yeah, right. Okay, so I'm gonna be 0.2 on this. Yeah. Is it gonna work? Yes, that's right. And it looks like there's another chamfer on the bottom. So let's go add in that other chamfer, which is here. That one is 0.1. That did not look like 0.1. Let's go change that. 0.1, there we go. All right, there's a hole. That's what we want for the hole. I think that's the entire hole. Let's go see if we can take all of these and pattern them. I don't know if it will work. Let's see. It's this one all the way down to the bottom. Let's make ourselves a circular pattern that is circled around this thing. We had 5 last time in our pattern, 5 this time in our pattern. We are very close to the end of this geometry. Now is a good time for us to see, ooh, we have not applied any material, which is not cool. I usually like to do that at the very, very beginning. Magnesium alloy, other alloys. So SolidWorks materials, other alloys, magnesium, apply, close. Let's turn off this stuff. I'm not entirely sure if I've gotten all of the features. I need to go back and just take a look at the engineering drawings in a moment. But I am going to just see how far away I am on my mass. This says 38.35, 38.14, 38.14. Okay, so I'm off just a little bit. Let's try to see where I might be off. Oh, I'm supposed to make a cutout here in the middle, which I never did. Okay, so that's great. Where am I going to find that one? Okay, excellent. I'm glad I found that fast. Didn't have to think too long about that one. On this plane 5, edit sketch, or make a sketch, excuse me. I am going to make a circle. Part of what happened is when I did my mass analysis, I saw I was too heavy. So I knew there was a spot where I was going to need to be removing material instead of adding material. You know, like a fillet in some cases adds material. I knew that I was going to need to find a spot where I was removing material. All right, now I want to do with this one what we did just previously. We're going to do an extrude cut, and I'm going to do an offset from a surface. And in this case, I'm going to offset from here, and it looks like the size I'm going to offset is 2.8. All right, I'm going to guess that, we're going to be way closer on the actual mass size now. Yeah, there we go. Save. Evaluate mass properties. 38.29. 38.14. Well, that's close. Okay, let's see if I can observe any other mistakes quickly here. Okay, I'm pretty sure section AA is correct. I'm just sort of envisioning this. So actually, it's a good idea for me to actually just go create section AA and look at it as if I'm looking at section AA. And this will help me observe if I'm seeing anything that's different. Okay, I don't have a fillet in here. That's interesting. Well, what's extra interesting about that is that that's going to make me heavier. That's okay. Better for me to go add in that feature because it should be there. Even if it causes my mass to be off a little bit more, I prefer that I get the thing the way we want it to be. So it's not what I wanted. Clear that. And that's a 0.1. That makes sense that we would have a fillet down there from a mechanical point of view. We want to reduce stress riser in that area. Okay, I'm going to go back here. I'm just sort of checking as I'm going along. I think that is right. I could double check this, which I'll do real fast. This should be 0.28. Excuse me, 2.8, which it is. Okay, and then this one of these, this one should be 2.2, and it is, so that's good. I think this cross section is right. Okay, let's save this. File, save. Okay, and then there's the lofts. Okay, so I'm pretty comfortable with sheet 2. I'm also comfortable with sheet... Also comfortable with sheet 4. I have all those features in there. The assembly drawing doesn't really tell me very much that is important. And then I have the cross sections. And the cross sections are, satisfactory to me. So I'm just going to take that and go with it, though my mass is slightly off. Okay, so I think we're just about done with our geometry. Let's see what's going on over here. Okay, I'm just going to check that mass one more time. Okay, 3.29. I'm not entirely sure why it didn't change. It should have just gotten more heavy because I added fillet in there. An inside fillet, which added material, but maybe it's strange that it didn't add anything, but that's okay. We are close. I think we're close enough on this. Of course, I have 2 more hours that I could spend on the test, double check some things, but I don't think I really need to do that right now. What I need to do is I'm going to go on to part number 2 in the test because I'm done with part number 1, which means I'm essentially done with the engineering drawings. And at this point, it's a matter of let's get the appearances to be right. So I'm going to adjust the appearance of the model. Okay. Adjust the appearance of the rim model. Use the supplied BMW decal and the color requirements below to know how to adjust the color. Make the entire rim painted car, make it rim painted car black. Wow, is that a thing? Okay, let's just see if this engineering drawing is any good. Appearances, painted car, haha, here we go, black. I'm gonna do this to the entire body. That only makes it like impossible to see. Let's do this. There, that's a little bit easier to see. Let's turn off these things. We're not going to need those. For the surfaces shown as light metallic color, use metallic cool gray. Okay, here we go. All right. First of all, there's also a note here pointing right at the BMW thing that says this one needs to be white. So let's just go do that. Let's do that on that entire operation. Okay, that one's going to be white. And then all these other ones are gray. So let's just go pick those. That's going to be slightly annoying because I'm not sure how to do that fast. So I'm going to have to do it slow. Okay. What have we learned from doing this test? I don't know. Break down the product from its complex shape into something simpler. I think I failed on that maybe while I was talking. Use the master modeling. I do like master modeling. It's sort of difficult to do when you're not used to it. When you do get used to it, it actually saves a lot of time. Okay, cool gray, cool gray, cool gray. Let's keep going. Cool gray. Okay, we only have, I don't know, 4 more surfaces to do, except that's not true because there's still a few others that we need to color. Face. Cool gray. And there's 2 more left to do on this set. And then we're going to save this thing because I don't want to have to click all these buttons one more time. Okay, great. That's looking pretty good. Save that. And then it says that, okay, there's a few more surfaces here. Okay. I'm looking right now at figure 1112 in the test. That's telling me what I should be doing to get the appearance right. All right, now I need to go in and get the these guys right in here. Yes, apply that to the whole circular pattern. Can I do it? Yes, wonderful. Now it did that to the pattern. I just have to go do it to the original one. Okay, I think I have to do this one piecewise. Cut. Okay, wonderful. Now, into here. You know, I usually like to do my CAD work early in the morning. It's late in the afternoon. Means I'm a little slower than I want to be. I think it's good to get to know yourself and what you're good at and when you're good at it, and then put yourself to work on the things you're good at the time of the day that you're good at them. Okay, let's look at this in perspective view because I always think that looks a little bit better. Okay, before we put in the decal, actually, let's just stick in the decal. All right, go into render tools. Let's go edit a decal. Let's go find the decal. We want to go into wherever that was. Not there. Here it is. This one. I need to choose a face to have that go on. I want to use the image alpha graphics channel. Just gonna put it like that. I don't need to adjust it at all to make it look right. That's good. Save that. Okay, now let's go see what our actual wheel assembly looks like. Ooh, beautiful. Be looking pretty good there. Let's see, we're in the 20-inch configuration. Actually, the default and 20 are the same. Please work. Let's see, the 23-inch. Got to give it a check mark there. There it is. There's the big one. Versus the small one. All right. What left do we have to do? Let's see. I have adjusted the appearances. I have used the master model to demonstrate that it works. So I've done 1, 2, and 3. Need to do an interference analysis, which says do an interference analysis for the 23-inch and the 20-inch. So we're on 20-inch right now. Let's go into evaluate. Let's do our interference detection. Let's calculate. Calculating. I expect to see no interferences. No interferences. Wonderful. So my answer to that one is 0 interferences. Let's get out of this thing. Come over here. Switch this to the 23-inch configuration. Once we're on the 23-inch configuration, we're going to go back into evaluate. Oh, here we're already in evaluate. We're going to run this again, and no interferences. Perfect. So that is our answer there. Okay, now what we need to do, is we need to figure out what size should these holes be for the lug bolts to pass through them. It is a 1/2 inch bolt with 20 threads per inch, and I want to have a free fit clearance. All right, how am I going to do this? Well, first of all, I don't have a lot of options here except to trouble you with me going all the way over to Learning Suite, okay, which I'm going to do right now. Get into here. Got to do my dual authentication. Okay, this is wonderful. Sorry you have to be seeing any of this. Okay. And I need to go into here, and then into here, and then into the guidebook. And once we are in the guidebook, we're going to go to Chapter 8 in the guidebook, where Chapter 8 go right here. And we are going to find the table that tells us how to do this. And the table that tells us how to do this is this one right here, Table 812. And what 812 is telling us is these are the tap drills and clearance drills for the screws that we're going to use. In this case, they're bolts. We are going to have a 1/2 inch bolt, which is down at the very bottom of this. Okay, I guess I can be kind and try to figure out how to zoom in here. Here we go. And we will zoom out just a little bit here. Okay, 1/2 inch bolt, 20 threads per inch. One of these numbers in this row is valuable to me. Let's see if we can see here. Clearance hole drills, free fit. That's exactly what we want, is a free fit. So the answer to this is that the holes should be 0.5312. If that is the size, then we have a nice free fit for those lug bolts to pass through the product. Okay, that's it for the test. We are done with that. If I were taking the test and turning it in, I'd have to make some screenshots, save something as, a pack and go and get that put in. But this is the test. I'm just going to pause for a second about what made the test successful for me as I just worked on this. Well, number one, while there was just one part, which is the rim, I allowed myself to think of it as existing in 3 major chunks. The full outside part, which I made with surfaces, connecting to the actual tire, and then turning it into a solid. That was one thing I did. And then I said, well, let me make the spokes. And so I made the spokes as solids. I didn't need to make those as surfaces. And I said, let me make the hub. I made the hub as a solid. I didn't need to make it as surfaces. And all of these surfaces sort of intersected with each other to create the the rim as a whole. Now, throughout the process, at each step, I checked to see that my master modeling was working. That if I changed the tire size, I would get myself an adjusting outer rim, an adjusting spoke, and the center hub doesn't adjust, but I could check to see that it wasn't going to adjust. I checked my mass properties as I went along. My mass is not exactly what the engineering drawing says, but it's close, and I checked to see my features are there. And in the checking, I did see that I had forgotten a feature, 2 features. Went in and put those in, but didn't change the mass significantly, at least not in the analysis that we did. Then I went in, took care of all the appearances, took care of all of the interferences that needed to be done, And then as I sized the holes for the lug bolts to pass through, I used the table in the guidebook that tells us the sizes that are needed for a free fit. Okay, that is it. Hopefully that was helpful for you, and thank you.